In this video, we're going to take a look at combustion reactions. So we're going to see how to identify them and also predict products of them. We're also going to see the difference between complete and incomplete combustions. So all a combustion really is you're taking a fuel, you're reacting it with oxygen, and when it does that, it will release heat. And oftentimes you see that heat released in with flames that are associated with, not all the time. So one type of combustion you might see is a element reacting with oxygen. So this is actually another type of synthesis reaction. When you think about it, if you have metal and oxygen reacting, it'll make a metal oxide. If you have a non-metal and oxygen reacting, it'll make a non-metal oxide. So even though this is really just synthesis, it is also a combustion. It's combustion of a specific element. So you might have iron and oxygen reacting to form an iron oxide, and that there would be rusting, which is an example of combustion. Slow combustion, but still happening. So you can have combustion of elements. But what we also focus on quite a bit in grade 11 is the combustion of hydrocarbons and other organic compounds. So hydrocarbons in general are chemicals that have a whole bunch of carbon and hydrogen. So in fact, a hydrocarbon is purely hydrogen and carbon. We put CXHY to say that there's a certain number here. So for example, C4H10, a whole bunch of carbons and hydrogens attached together is a hydrocarbon. So you can see a bunch of hydrocarbons over here. And you can also have modifications of this. So you could have C and H's and then an O or an N, and those can serve as fuel as well. And you just basically make them react with oxygen and you get energy released. So, for example, gasoline that you put in your car is a hydrocarbon. And so when you turn on your engine and the reactions happen, you allow it to combust. It releases its products, and it also releases energy, which allows your car to move, your vehicle to move. So these are just some examples of hydrocarbons over here, and we'll take a look at some more. In general, when we take a look at hydrocarbons, one type of combustion that can happen with them is complete combustion. That means you have a lot or more than enough oxygen present. And so usually it looks something like this. You have your hydrocarbon over here, you have your reacting with oxygen over here, arrow, CO2 gas, and H2O gas. And then you can write plus energy as well because it releases energy, which you remember being called, let's see, when you release energy, that's not endothermic, but that's right, exothermic. So you could write plus energy there. But essentially, it doesn't matter what your hydrocarbon is, you're always going to have the same products at the end, CO2 and H2O, plus energy. It'll just balance a little bit differently. But that's assuming we say it's a complete combustion, or we say when there's abundant or excess oxygen present, then you can assume that you're going to have a complete combustion. You can watch this video for some more details, but oftentimes the flame of a complete combustion reaction is going to be blue, and the flame of an incomplete combustion reaction is going to be more of the orange color. We'll do some examples of complete combustion afterwards, and then we'll do some balancing. And then we'll take a look at incomplete combustion reactions. So incomplete combustion reactions are still combustion. We have a hydrocarbon reacting with oxygen in a much similar way we had before, except this time it's going to be when there's not enough oxygen. There's insufficient oxygen. And usually we get an orange flame. So what products do you get when you do this? Well, you get carbon dioxide and water like normally, but you also get this dangerous stuff, carbon monoxide, and then soot, which is just solid carbon. So carbon monoxide is the silent killer. You can't smell it. It's odorless. It's transparent. There's no color, so you can't see it either, and it will kill you. So that's why you might have a carbon monoxide detector in your home to detect carbon monoxide if it's there. There'll be like a little chemical strip in the little machinery. It'll react with the strip if there's a lot there, or you might have an electronic one. And if it's very, very high levels or high enough levels, it'll beep to let you know, and you got to get that taken care of right away because this will actually prevent you from binding oxygen in your blood, and you won't be able to breathe essentially. So that's what an incomplete combustion produces, these four products here, whereas complete is only these two products. How would you know which one's which when you have a reaction? You'd have to be given some information. For example, there's not enough oxygen, insufficient oxygen would be incomplete, insufficient, incomplete, or abundant or excess would be considered complete. There's a great video demo for you to watch over here. I recommend you watch it regarding incomplete combustion. And then also, please make sure you watch this video on carbon monoxide poisoning and why it's important to have carbon monoxide detectors in your home. So we'll do some examples together here, and then we'll do a couple more examples where we're writing out some reactions, word equations, and skeleton equations and balance equations from a description. Once we're done all that, I do want you to watch the Concerns with Combustions video. It's an acid rain video again. So you'll watch that video, and you're going to be able to explain at the end of it where different sources of acid come from and how it's related to acid rain comes from and how it's related to combustion reactions. So please make sure you watch this. Make sure you understand that when you burn fuel sources, you release a bunch of byproducts which will react in the atmosphere to produce acid, and that will go into a rain. So watch that video to get a better understanding of it and summarize the reactions that occur and have a good understanding to explain how those reactions occur once you're done watching the video. This is an answer key to take a look at the different reactions involved in the different acids in acid rain, but again, you'll see most of that in the video. Let's go ahead and do some examples in our handout for combustion reactions. So let's start off with combustion of elements. So remember, actually, first of all, that combustion is always when you take a fuel, you burn it in the presence of oxygen, and you give off heat and energy and exhaust. And so it'll look something like this. Either you have a hydrocarbon or an element reacting with oxygen, and you produce various products depending on what you have. So the first type of combustion is combustion of elements, where you have a metal or a nonmetal, so that's your element, reacting with oxygen. And that will produce some kind of oxide compound. So this is essentially a type of synthesis. So here we have one case is a metal and oxygen, give you a metallic oxide. So here we have a metal and oxygen, and it'll give us MgO, solid. And we figured that out because we did the crisscross between Mg and O. And then here we have a non-metal and oxygen gives us a non-metal oxide. So we have carbon and oxygen gives us, for example, CO2 gas. And again, these are the same as we saw above for synthesis, but they're specifically combustion of elements because we're reacting with O2 there. You might see that as well for iron, for example, reacting. Let's take a look at iron reacting with oxygen to get an iron oxide, which I mentioned before was like rust. So those are that's combustion of elements, but you can also have combustion of hydrocarbons, which have this general formula here, CXHY. So, for example, that could be methane, CH4. It could be something called butane, C4H10. It could be something called propane, C3H8. You're not required to know all of these formulas yet. You'll be given these when you have hydrocarbon reactions to write out. So essentially, it's just a whole bunch of carbon-hydrogen compounds that have a lot of energy in their carbon-carbon and carbon-hydrogen bonds. And so when you burn them in the presence of oxygen, they're going to release energy for us to use. So if you burn, let's say, propane, it's going to release energy for you to cook meat on a barbecue. If you burn butane, it'll release the energy that comes out of a lighter. If you burn methane in the presence of oxygen, you'll get the flame of a Bunsen burner. So they have a lot of energy in them. To get it out, you need to burn it with oxygen. And hydrocarbons can also be, there's derivatives of hydrocarbons, so other organic compounds. So for example, you might have compounds that have CX and O, CX and N. One great example that you might know is C6H12O6. This is glucose, or a type of sugar, which you break down during cellular respiration. So complete combustion is one type of hydrocarbon combustion. It's when you have a hydrocarbon burned in the presence of excess or sufficient oxygen. There's a lot of oxygen there. And so when that happens, you get two things produced. You get water, and then you also get carbon dioxide. And that's it. It doesn't matter what the hydrocarbon is. So for example, if I have CH4 gas and O2 gas, and I tell you there's a lot of O2, I tell you there's abundant or excess O2, you would simply put CO2 plus H2O, and they're both in their gas state. And you could also add plus energy because, well, there's energy released. So this is very similar. It's not quite a hydrocarbon. It's actually something else called an alcohol, and I know that because of the OH there. But that's okay. It's very similar to a hydrocarbon. We have it reacting with oxygen. We'll assume it's going to be complete combustion, but again, I would give you more information to figure that out later on. We'd have CO2 gas plus H2O gas plus energy. And so you'll always have the same products, just the balancing will be a little bit different because you have, well, different compounds. So you could go ahead and try to balance those. But essentially, complete combustion. And remember that for complete combustion, the flame, this is supposed to be a flame here, is blue in general. Next, we're going to try to do incomplete combustion. So that's where you have a hydrocarbon. It's burned in the presence of limited or insufficient oxygen, not enough oxygen there. And when that happens, you get the following things produced: water, carbon dioxide, carbon monoxide, and then also soot, which is just regular carbon. So notice how I just took the same equations from here and here, and I brought them here. We're going to apply them as incomplete combustions. So we'll get our H2O gas, our CO2 gas, our carbon monoxide gas, and our soot, which is solid. Same idea here, so it's still H2O gas plus CO2 gas plus CO gas, carbon monoxide, the silent killer, plus soot, solid. And that's because we have an incomplete combustion. And so again, even though it's all the same products, it'll still differ in the way you balance it. So this one here will be balanced a little bit differently from this one here. And you can go ahead and try those out. And you can see in your answer key that I posted online if you are correct in the balancing that you did there. So we're going to try this one out here. We're going to write a balanced chemical equation when C3H8 is burned with excess oxygen. So let's go ahead and write that out. So we have excess oxygen. So what does that mean? We know it's a complete combustion. Complete combustion. And so we'll get C3H8. We'll put it as a gas. If it's combustion, it's reacting with oxygen, which is a gas as well. And it's going to produce some CO2 gas because it's a complete combustion here, plus H2O, gas, plus energy. And it's that energy you would use to grill something on a barbecue. And so we can go ahead and balance this. So let's take a look. I need 3 carbons. I need 8 H's. But now I have, let's see, 3 times 2 plus 4. So that's 10. 10 oxygens, right? Yep. So to get 10 oxygens, I can do 5 there. I put a 1 there. So 3 carbons, 8 H's, 8 H's, and then 6 plus 4, 10. So I put a 5 there, 10 total. So that would be the complete combustion reaction, but you could also write this as a, well, limited oxygen present, so as an incomplete combustion. And so we'll go ahead and do that. We'll do C3H8, the start's still the same, plus O2. And then we're going to provide or produce CO2 gas plus H2O gas plus CO gas plus C solid. And then we'll put energy over here because energy is also released. You're in a combustion reaction. So now we have to balance this to make sure we're on the right track. Let's see. So we want to get 8 H's on both sides. So I'll put a 4 over here just to get 8 H's. For carbons, we need 3 carbons. And it looks like we have 3 carbons because we have a carbon here, here, and here. So we really just need to balance our oxygen. So oxygen we have 2, 4 times 1. So that's 6, 7. 7 oxygens. So what I'll do is I'll do my little cheat method. I'll do 7.5 over here. And then I'll multiply everything by 2. And so I think that should work. I'll get 2 C3H8 gas plus 7 O2 gas produces 2 CO2 gas plus 8 H2O gas plus 2CO gas plus 2C solid. Now, I don't know if I made a mistake here, but let's see. So 6 carbons, 2 plus 2 plus 2, 6 carbons are there. 16 hydrogens. Okay, for oxygen, I have 14. So 4 plus 8, that's 12, plus 2, that's 14. So now it's fully balanced for my incomplete combustion reaction. So the last part of the lesson is for you to go through the combustion problem. So when we burn fuel, there are some problems with that. The fuel we burn often has impurities like sulfur and heavy metals in it, and that can cause air pollution, which can lead to the production of acid rain. And so I want you to watch the video of acid rain and write down the series of equations that leads to the formation of nitric acid and acid rain, and make sure you balance the reaction and classify it as well. And then also do the same thing, but for sulfuric acid and acid rain. Balance and classify the reactions that are involved. And that's the answers are included, like I said, in the slide deck, and they're also in the video that you're going to watch. So that sums up the combustion reactions. Make sure you're able to predict products, whether it's a combustion of elements, combustion of hydrocarbons as complete or incomplete combustions. Make sure you can balance them. And as a rule of thumb, I would generally recommend adding plus energy at the end of all your combustion reactions because they are exothermic for your combustion reaction specifically.